Well, good afternoon, everybody. It's 3:20 p.m. on Thursday as we begin to navigate the new normal for us. So remember, everything here is optional. If you don't have time because you're sick or you're busy or whatever, I'm just trying to get you the information as best I can. I'll have questions for you to answer. Do as much or as little as you want. It's going to be whatever you want to put into it. And I understand we're all in a different boat. So at the end of the semester, you're going to tell me, I think I deserve this grade because, and I'm going to simply read your paragraph and give you that grade. That's basically how it goes. So don't be afraid to try. Don't be afraid to get things wrong. And like I said, you're going to get as much out of it as you put in. And some of you want to get a lot, and some of you either don't want to or you're pulled in a lot of different directions right now. So I'm not going to critique or judge anyway. I'm just going to keep presenting as best I can. At the moment, what I'm going to do is I'm going to go through some of these slides that we have and give you a little narration so that you can hopefully get a little extra out of it. We'll do classroom office hours, so to speak, using Google Meet. We'll do Mondays in the morning. I'll give you a time once I coordinate with Mrs. Lohr, and then on Wednesday we'll do in the PM. And then on Friday, for the 5th hour, folks, we'll do in the morning again. Join any time you want. If you're free Monday in the morning, you'll know when those Google Meets are going to be. Join in anytime. Come in for a second or a third if you want, whatever. You do whatever it is you need to do. So the intention today is to go through, recap what we've already done, and kind of move forward. As we go through, feel free to pause the video. I'm going to ask questions that I'm going to send out to you through a Google form. I'll ask the questions on here as well so you can see where they show up. But my suggestion here would be go to Edmodo or go to Google Classroom and find the PDF that I have saved. And it's going to be all the slides I have on here so you can look at them side by side if you want. So that's going to be my suggestion. And as we go through, if we figure out better ways to do things, you're going to tell me, and that's what we're going to do. So looking at this first slide, it's the PowerPoint that we had all consolidated down, whether it's talking about your subatomic particles here, whether it's talking about the charge being the same, despite having different sizes, different masses, they still have the same amount of charge. So electrons and protons cancel each other out. We talked about conservation. We talked about how to make something charged. And then we had 3 rules that we started with. Electrons being the movers, knowing where they go and where they come from, and then knowing that charge is just an imbalance. So once we know that we have too many or too few electrons, that's how we gain our charge. So if I go to page number 2 of the PDF, we had to make a guess for the C tape, which was the same as the A and the B tape. We had to make a guess. So we said, all right, if you thought the tape was negative, this had to happen. If you thought the tape was positive, that had to happen. And then based on what D and E did, we said, all right, well, if we thought E was positive, this has to happen. If we thought E was negative, that has to happen. And so we had done that. You had to make a guess. You had a 50-50 shot at guessing correctly. And so we came up with rule number 4. Rule 4 was charged objects attract neutral objects. We saw that first, technically, when I took a balloon, rubbed it in my hair, and stuck it to the ceiling. And then we also saw a straw doing that with the teeny little bits of paper. The paper, nothing changed with the paper, but we rubbed the straw through our hair. So that was proof. Rule number 5. We could do it logically. A, B, and C tape, they all got charged the same way. It's all the same tape, the same desktop, the same method, the same everything. So it makes perfect sense, logical sense, that these objects must have like charges. That is a definite. There's no reason to assume otherwise because we did all the same stuff. And what did we see? Simple. They repelled. So there's our rule. If they're the same charge, they repel. And we saw that with proof. And then we ended with rule number 6. You ripped D and E apart. We saw that E repelled C. So that tells us that they have to have the same charge because we have rule 5. In order to become charged, E must have taken or given electrons with the only thing it came in contact with, which was D. So, no matter what your guess was, whether you were right or wrong, it makes perfect logical sense that D has to be opposite of E. If E gained negatives, that leaves D as a positive. If E gave away negatives, that makes D negative and E positive. So no matter what, we saw two oppositely charged tapes, and what did we see? They attracted. So there's rule 6. Be careful, rule 4 and rule 6 both involve attract. So in terms of how you're able to answer questions, keep that in mind. So I believe this is going to be page number, that was page number 3, so now I'm on to page number 4. We didn't really talk about this one, but it doesn't take much time. When you held two tapes far away from each other, you didn't see any reaction. It wasn't until they got close. This is telling us that our force is inversely proportional to the distance. We could do some further studies and figure out that our force is inversely proportional to d squared, but that squared right now doesn't really matter. All that matters is when you're close, you get a strong force, whether it's an attraction or repulsion. When you're far away, the force is reduced, and that's going to have some pretty big effects on us, starting in this particular lecture, moving on to the next couple days' work. We slide on down. What else do we do in class? We took styrofoam. We explained how we know styrofoam to be negative based on the materials. And we saw that it repelled the C tape really, really well. I could be quite a distance away and get a pretty good reaction from your tape. So this told us a couple things. Number one, it told us that C was negative. We said C tape is super small, which is convenient. All it takes is a little small amount of force, attraction, or repulsion, and we'll see the tape literally move. And that's going to allow us to know the charges of other things. So tape was a great tester. I don't know if it's going to be question number 1 exactly once I organize everything, but one of your first questions is going to be right here. The styrofoam pushed the tape so well. We know Newton's third law is a thing, right? So we know that the styrofoam and the tape both felt the same amount of force. We know the styrofoam was really big and heavy, so we didn't see any reaction, but we know it felt the same thing. My question is, why do you think, and you can just take a guess, there's no, there's no worry about getting it wrong. Why do you think the styrofoam was able to push the tape with so much strength when a second piece of tape couldn't push with that same amount of strength? And that'll be something we talk about next time around. Okay, our next page here is going to be page number 5. I'm forgetting all my page numbers. Page number 5. So, based on the reaction that we saw with our C tape, we know that C tape is negative. We actually just said that, 30 seconds ago. So C tape is negative, so that's a great tester. C tape repelled E and it repelled the straw, so plain and simple, got to be the same charge, negative. And you made a guess earlier on what you thought C tape was, and if you were wrong, it wasn't a big deal. I said, don't worry about it. We'll have time and place to correct it. C was attracted to D, and we knew D had to be charged because D and E charged each other, so D must be positive. I'm looking at that, so D's got to be positive. So when I come down here, the correct charging method. You made a guess before that might be incorrect. Well, now here it is correct. We know C must have taken electrons from the desk, making it negative. We know that E takes electrons from D, and this makes C negative, E negative, and D positive. And we drew that on the last page of the lab. We drew that. That was at least what you were expected to draw down to finish that page. So now moving forward, this is brand new to us. We are going to start drawing objects with charges. And I've got my own personal 4 steps. I got my 6 rules for electrostatics. Now I've got my 4 steps for drawing charge. First, draw your object. Draw it as a square, a circle, a trapezoid, a rectangle, any shape you want. If you want to make the shape kind of match your real life object, then by all means, I would suggest doing that. Number 2, draw yourself a grid of positives. Your object has structure because of the nuclei that are all arranged in a grid. And we're ignoring the electric effects of the neutrons because they don't really have much of an electric effect. So basically for us, the positives in the nucleus, they make up the structure. So you have to have a grid. You can't have them all bunched up in one spot. Next, this is something in your head, how many negatives do I need? And the question is, well, is your object neutral? Is it positive? Or is it negative? Because that's going to tell you how many negatives you're going to need. Last, draw those negatives. We know the negatives are located outside of the nucleus. They're going around, they're moving. So where would you expect to see those negatives, some finite number that you determined right here, where would you expect to find those? And you can use rule 5 and 6 for that. Are they being attracted or repelled by anything? If the answer is no to both of those, then you draw them equally spread out everywhere. If you do have something pushing or pulling on those negatives, only the negatives can move. Rule number 1, draw them where they should go. The positives are locked in place. They are locked in right here, our grid. They're locked in. So if I were to go through and look at my picture, first, one on the left-hand side, I got a bunch of positives all bunched up on one side. If I stop there, that's no good. That is a no. On the right-hand side, I've got them drawn out there. Don't go crazy. Don't draw 20, 30, 40 plus signs. Draw 4, draw 6, draw 8. Draw something very small and neat and manageable. So for me, 6 looks like a nice number, a nice even grid. So there's step number 2. Step number 3 would be to make this object positive, negative, or neutral. What do I have to do? You see your answers on the PDF if you were actually looking at the PDF, but if I want to make it neutral, I had 6 plus signs. To make it neutral means I'm going to need to have 6 negative signs. So literally 6 minus signs in that picture, no matter where I draw them, is going to make the object neutral. If it's negative, I need more negatives than positives. The electrons are the negatives, so I need more than 6. To make it positive, I just have to have a number of negatives that is going to be fewer than the number 6, so 5 or less. We can't have a negative amount of electrons. Yes, an electron is negative, but I can't have a negative amount of them, so between 0 and 5 would be what I need. And you know what? I'm looking at this, and I realized the previous slide, this force proportional to 1 over d squared, that has a name, Coulomb's law. That's one part of a bigger equation that we will talk about later. So there is that. That is page number 6. And, all right, so I think I forgot a page here, but whatever. So this is how we're going to end. Now that we know what we know, I have some big positively charged object. I don't know what it is. Our D tape was positive, so I put the letter D here. It doesn't have to be tape, but you get the idea. I got a big positive object that is next to, right here, a neutral object. Maybe that's straw and a piece of paper. Maybe it's a balloon and a ceiling. Doesn't matter. This down here is neutral. So right there, neutral. This thing is a positive. This thing is a negative next to another neutral. The question here says, draw the proper number and the proper location of the electrons in each neutral pink object. So how many negatives do I need, and where am I going to find them if I got a big plus sign sitting right here? Same thing over here. How many negatives do I need here, and where would I find them if a big negative is sitting right there? And as I scroll down, once you've done the diagrams, what do you think the pink object is going to do in each of the pictures? And I'll give you some options on our Google form. And last, final page here. This is page number 8, and so I think I maybe need to fix what I've saved, but regardless, write a short statement. So I want literally one short sentence. I don't want this long, drawn-out paragraph. Just a simple short sentence. I want it to be 100% true. I don't want an either or a maybe. I want this is fact. I see 2 objects. I have no idea what these objects are, but I see these 2 objects, the red and the blue. I see them repel each other. I know nothing about them besides the repulsion. And at the bottom, 2 completely different objects. I bring them close together, and I notice that they attract each other. So in both of these, what is the most accurate, short statement you can tell me about these scenarios. So I'm going to have these in a Google form, and like I said, give them a shot. And I'm trying to figure out if I'll give answers during the office hours or if I'll just post the answers next Friday during our video before we go on to the next. Um, we'll figure that out as we get to it. So that's it. That's the beginning of the end for us, I guess. But so that's how we'll start with things, and I will gladly accept all of your feedback and criticism and everything else to make this better and better. Um, in case you're curious, what we just did right here would have taken us probably about a half of a class. I'm going to offer up some worksheets from my Edmodo and Google Classroom that you can look at if you want. Solutions are posted. We can't, we're not going to be going through 5 days, 1 week's worth of information each week because that's just not practical with your time and what you have to do. So um, I will try to pick up the pace a little bit to maybe get a little bit more than just 1 day per week, but we'll take what we can get. So I miss you all. I hope everyone is doing well. Everyone is healthy, and physics should be on the back burner when more important things spring up, whether it's health, whether it's family, whether it's whatever. So put in as much time as you can, as much time as you want, and I'm going to keep giving you physics information. So I hope to see you all soon, even if it's just through my computer screen. So with that, we will see you next time.